Hi, my name is Eric Plumley. I'm the Chief Technology Officer at Neurolenses. Welcome to the virtual trade booth. We're going to do a demo. We're going to show you how the machine works so you understand the patient experience. So the first step, the patient's been entered in the system. They've answered their lifestyle questions as far as what their symptoms are. And I'm going to line them up in the machine, and we're going to set the eye tracking. Once the eye tracking is set, we're going to go ahead and hit go. The system's entirely objective, so the patient is always instructed to look at the target. So they're seeing a target throughout the test. The eye tracking system itself determines the direction of gaze so that we always know the measurement's objective. That's how we're able to get a more repeatable measurement. At this step here, we've disassociated the patient. So one eye is looking at the target and the other eye is seeing a disassociated graphic, and you're going to see here now the left eye is looking at a target and the right eye is looking at a disassociated graphic. Again, our eye tracker is looking at the direction of gaze of the eye. I don't have to ask the patient, tell me when things are lining up. We do a little exercise here where we pull the patient's eyes apart to reduce the proximal convergence. Then we fuse them again in the periphery, and we alternate a central target. This is kind of a residual fixation disparity test, so we're looking at their fixation disparity. Tom didn't have any there, so we said, okay, we're good to go. Now we change the lenses in the device so that we can stimulate the accommodative system. We're going to look at how his eyes turn in, so basically looking at how his vergent system works with his accommodative system. And it's the same test sequence as before, so we initially are going to measure the pupillary distance, then we're going to disassociate them, and if you look closely in this, you'll be able to see his eyes move to a phoretic posture. In a second here, you'll see that his right eye is going to be looking at the target. He's always looking at the target. If the patient ever says they can't see the target, they're probably suppressing vision in that eye, which is useful information as a practitioner as well. We have information at the end that might help lead you to clues about that as well. Okay, so now the left eye is looking at the target, and we're looking at the right eye phoretic posture. All right, the target's going to come back in the middle, again fused in the periphery. And if we detect eye movement in this step, we will adjust the target position. The whole goal is to neutralize his eye movement. That way we know that we have him in the most comfortable position. And we went ahead and we're all done there. So go ahead and lean back, Tom, you're all done. Okay, now looking at the measurement that we got from him, we have a distance and a near PD. Keep in mind the near PD is at the pupil plane, not the spectacle plane, so it's not a typical 3 millimeters, it's usually 1 to 1.5 difference. MQI, that tells us, hey, we were able to get a good measurement on him. If it's too low, we'll throw out the measurement and let you know that we didn't get an accurate measurement. We have a horizontal near measurement, 1.55. I'm sorry, that's the distance measurement, 1.55. Exo, near measurement, 6.6 exo. A little bit of right hyper in both eyes. And we had good measurement quality on everything. We calculated ACA. It's a gradient ACA using the distance and near measurement of 3.82, and then we have a Neurolens value for his profile. We're saying that 1.3 base in would be the Neurolens prescription that we found to work best for a patient like that. So we boil all the 10,000 data points that we get into one number so that it's easy for the doctor to know how to prescribe. That's based on outcomes in our database. To explain it to the patient, we created a graphic, and this is all available on the portal as well. So we're looking at the red line, that's where the patient's eyes wanted to be. The green line is where they need to be. If you look, his near measurement was much more exophoric, so we illustrate that for him. If a patient like him is having symptoms, we're saying absolutely you're the exact patient that we're trying to help with the Neurolenses. And then if you really want to dive down deep, you can go into the 10,000 data points. So we're looking at not just what the patient's phoretic posture was, but how long did it take to get them? What's that slope look like? This is information you can't get with, a cover test and things like that. Where most measurements would be one number, we're actually collecting thousands of data points. Okay, that's it. Thank you.